What's the digits we're looking at here, Lauren? 17, that's what I thought too. All right, we're looking at day 17 and we're gonna do some prep work for 12.1 through 12.3. In 12.2 and 12.3, 12.1 is the distance formula, and so this is just gonna be a lot of calculations practice today. And reminder of how to do stuff here. 12.2 and 12.3, we're working with stuff that will have us doing complete the square. And since I know that was everyone's favorite fucking topic, I think we'd hit it, thought we'd hit it again. So. What's the distance formula look like? There's two things in 12.1, distance formula and midpoint. Midpoint's really easy, the distance formula is a little bit more confusing. Let's say I've got a point, this is x1, y1. And wow, down over here. X2, y2 is over here. The distance between these 2 points, this length here, I'll call it d. We'll show how to derive this formula in the next hour. But it is the square root of x2 minus x1 squared plus y2 minus y1 squared. I thought we'd do a little simple one first to get you familiar with how this works. Then we'll kick it up and make it more fun. So if I were to sketch this. One, 2 is right there. 5, 6 is right here. So we're looking at that length there. Now, just looking at like making a little triangle here. I want to have some like intuition show up here. This length here is 1, 2, 3, 4. And this length here is 1, 2, 3, 4. So like on the triangle, both sides are 4. The diagonal should be longer. That make sense? This is always a nice little simple check you can do. So we can call this 1.1, we can call this 1.2. So that's 1 and this is 2. So that makes this x1 and this is y1. X2 and y2. I'm just plugging in what we got. X2 is 5, x1 is 1, y2 is 6, and y1 is 2. Just to make sure. So, what is that? That's 4 squared and 4 squared? And rather than adding them together, I'm going to rewrite it like this. That is 2 times 4 squared. And we worked with radicals before. We can factor out this, the square and this square root cancel there. 4 comes out, and we've got 4 square root of 2. How big is that? I don't know. 5.66. Approximately. Which is bigger than 4. So good. That's the end. Let me give you guys one to try. You don't have to sketch the picture, but I did. A little bit longer, see when you're still working, I can see. All right, I'll call this one 0.2 this time, and this one 0.1. So I've got my x's are the 5 minus 7. And my y's are 6 minus 10. So that is -2 squared. And -4 squared. Which is 4 and 16. So square root of 20. That does simplify. We could turn this into 4 times 5. And so get 2 square root of 5. I think that's what you're about to say.
Yes.
That's probably the simpler way. Square root of 5 is a little bit above 2. Well, another way of looking at this. Square root of 16 is 4. Square root of 25 is 5. Like on a number line. 16, 25, 20 is a little bit closer here to 16. That would be 4. This would be 5. I'm guessing this is like 4.4-ish.
4.47.
4.47?
Yes.
Yeah, a little bit below 4.5. So you can estimate it without getting a calculator out. Just by comparing it to the next closest squares above it and below it. Was that fun?
Yeah.
Good. You're gonna like this then.
Yes.
Let's do another one. Now it looks a little intimidating, right? All those square roots.
Yes.
Let's just set up our generic version here and take a look what's happening, because it still might be intimidating.
I think you're on the focus.
I don't know that it's gonna get any clearer. All right, Sarah, which one should I make 0.1? Which one should I be 0.2? That's 1, that's 2. So we're doing x2 minus x1, so square root of 5 minus square root of 8 plus, and that's y2 minus y1, negative square root of 6 minus square root of 3. Alright, so let's do these separately. Let's call this A and let's call this B. So A, we've got square root of 5 minus square root of 8 squared. That's not just doing each one squared individually. We've got to distribute this. So we've got square root of 5 squared minus square root of 40 minus another square root of 40 plus square root of 8 squared. This is 5 minus 2 root 40 plus 8. And 40 is 4 times 10. So we can make that the 40 into a 2 root 10. And we got another 2. I'm going to combine this all together. I got 5 plus 8 is 13. And then minus 2 times 2 root 10 is minus 4 root 10. That's that first part squared. So I'm going to put a box around that. We're going to need that later on. That's A. B. I'll let you work that one out. Calculate what that part will be, and then we'll put them together. So we got a negative root 6 squared. And negative 6 times root 3, and negative root 3 is positive square root of 18. And then we got negative root 3 times negative root 6 is another positive square root of 18. And then we got negative times the negative is positive square root of 3 squared. So this gives us a 6. This gives us 2 root 18 and a 3. And so this is 9 plus 18 is 2 times 9. So we could make this like 3 root 2. So that's like 3 root 2 times 2 would be 6 root 2. Now, I don't know that that helped anybody cleaning that all up like that, but you never know. It's always worth doing. A was this. That's B. There's no real pretty answer to this. I mean, we could combine the 9 and 13 and get 22 plus 6 root 2 minus 4 root 10. But I don't know that it helps. Inside the radical, I'm getting, and this will be approximate because I'm rounding. So if I take the square root of that. Now, does that feel about right?
Yes.
So square root of 8, square root of 3. I'm gonna graph it and see if I can get like an estimate of how long it looks. Somewhere in there, that's the square root of 8 one. And 2.2 and down. That might be about 4. That looks like it's a little over 4. Huh. Okay. All right, one more. We won't go through the whole thing, but I want to remind you how to do some shit. So if I call this 1 and this one 2. The x value for x2 is 1/3. And I got minus -4/5. And then y2 is 3/4. And I got minus -2/3. So the minuses turn into a plus, right? It's a good spot to start. Eventually, we're gonna need a common denominator with everything. But if you just wanna make it simple to start with. Find a common denominator here first, so you can combine it. It's gonna make squaring easier. So I'll multiply this one by 5/5. Just multiply by the other denominator. So this parentheses turns into 5/15 plus 12/15 squared. And here I'll multiply by the other denominators on this one too. So here I got 3 times 3 is 9/12. And 8/12. So we got 17/15 squared. Plus 17/12 squared. If I multiply by the other denominators now. This denominator is 15 squared. That denominator is 12 squared. So I could write this as. I'm gonna leave the stuff I had in red alone. And just show doing that here. I'm gonna take the 15 and apply it there, so. Times 15 squared over 15 squared here. And here we're gonna do the 12 that way. 12 squared over 12 squared. I think that, okay, so 17 squared is 289. And 12 squared is 144. I don't know what all these are gonna be. Maybe I should leave that alone. We just got one big denominator now. And I've got 17 squared, 12 squared. Plus 17 squared, 15 squared. Over 15 squared, 12 squared. That's actually a good idea here. We can actually save ourselves a lot of work. Just by recognizing, well, first off, these two things can come out. The bottom without a square root is gonna be 15 times 12. The top, I could factor the 17 squared out. It's 12 squared plus 15 squared. Which means I can put the 17 outside here. And have 12 squared plus 15 squared. Inside the square root in here. I don't know if this is getting any plainer. 15 times 12 is 300. That is 144 plus 225. Which is 369. Is that 13 squared? No, that's not 13 squared. No, it's not, it's an irrational number. And 9 comes out of it though. This is 9 times 41. So I guess if I want to simplify it, I can have it times 3 times square root of 41. And the simplest form without a decimal is going to be that. Now, I ain't gonna have anything like this on the test, but I'm not confident that the homework isn't gonna give you fractions. So I wanted to make sure you guys like knew how to do it. I'm not gonna do the radicals either on the test. But I'm not confident that the homework won't give it to you, so when I mean radicals, I mean the radicals inside. The distance formula has a radical, there's no dodging that. But I don't know what the homework's gonna give you. Yeah,
That sounded like. You're stupid.
it's not a little wet, didn't it? Doesn't feel wet. Or does it? No, just fucking with you guys. Disgusting. Alright, so. Complete the square. 12.2 and 12.3 is gonna have us completing the square. Let's just run through a couple of them real quick as a reminder. How they work. Complete the square. We're gonna do it all on one side, so like say this is y equals. Nah, I don't wanna put anything there, I just wanna leave it as is, just as a reminder. So if we wanna complete the square. What we're doing is we're gonna create some space here. Move the minus 19 over, and we're trying to make parentheses here. And we're gonna take the 10 and we're gonna cut it in half. And we're gonna square it, so this is 5 squared. And so we're gonna add 5 squared, which is 25 inside. And I don't want to change the value of this, so to counteract a positive 25 on the outside or the inside, I'm gonna do minus 25 on the outside. Because there's no modifier on the 25. At that point, whatever we had here and its sign just falls down in parentheses.
You do a 44.
And 1925 is 44, yeah. Jackie, did you have a nice spring break with your little races?
No, we all got sick.
All right, next example. I'll move it over now, just give it a little room, let's say -10. And I'm making up numbers here. So when we make the parent, I guess I didn't need to, maybe I shouldn't have. Just put it all together. Because when I complete the square, I need to just have x squared here in front. Which means I need to factor out the 3. And so if I want to see what goes here, I do the -18 divided by the 3 we factored out. And I get -6. Everybody good with that so far?
Yes.
Okay, so when we did the complete the square, -6/2 is squared is -3 squared. So what I'm adding inside is 9. But collectively, I've added 3 times 9. Which is 27. So I've really overall added 27. Which means that's what I gotta subtract. -27, or I could just say -3 times 9. That might be the easier way to show it, if this ends up being the 27, but then you can see where it came from. So this falls into the parentheses with the sign. And then I've got 10 and 27 is -37. If you're not sure if you did it right, what can we do to check it?
Plug it back in.
Not so much plug it back in, but multiply this out and see if we get what we start with. Let's do that real quick, just as a like, because I know people get unreal, like they lose confidence in themselves, and they're not like, I don't even know if this is right. And then the rest of the problem feels shitty because you don't even know if this step's right. So you can always check it, like this is 3 times x minus 3 times x minus 3, and then -37. So this is x squared minus 3x minus 3x plus 9 minus 37. And I've got, if I group like terms there, that should be a plus. I'll distribute. And if I combine it back up, I see I got the right way to start with. So, like if you're doing this and it's on a test or something, you're like, I don't know that I did it right. Just fucking multiply back out on this scratch paper and make sure. Like you should get what you started with if everything went right. That's handy. Math is the only fucking subject that allows you to do this kind of shit. You don't get this in nursing. There's no putting the fucking medicine back in the bottle after you've injected a fucking patient. And they start fucking twitching because they have a seizure because you give them too much. It's too late. That's just ship sailed. You can't check it. That's a little graphic and fucking.
A little bit.
But that is the handy thing about math. Let's give you another one. As a fraction now. Let's give you this one to try. Why don't you guys try it for a couple minutes and then we'll do it together in like 4 minutes. Because I can speed run this shit. Okay, so. If I factor out the 1/2, what do I have there? I'm doing, just like I did before, I divided what I factored out of that, like that. So like I got a complex fraction here, I can multiply top and bottom by 2/1 and the bottom cancels,
So.
-14. Now we cut it in half. Square it. And I get 49/4. So I'm going to subtract 49/4 times that 1/2. That is multiplied by it. That gives us 1/2 x minus 7/2 squared. This looks like an 8 on bottom. So if I want to get the same value on, like combine these two, I gotta get a common denominator of 8. So I've got 80 minus 49 would be 31/8. Not the nicest number. But if you needed to graph it, you could turn it into a decimal and go from there. And that'll be it for Math 335. Let me hit stop record.